area of a rhombus. A rhombus can have two different orientations. You can think of it as a diamond shape, or you can think of it as a squished square, if you will. Because of this, because of these two orientations, we don't talk about it in the same way as we talk about area for the other subjects. We don't use base and height because it would be hard to say what the base and the height are. Instead, we use the diagonals. So the diagonals are from one vertex to the opposite vertex. So in both cases, we have a larger diagonal, which we're going to call capital D, and then we have a shorter diagonal, and here it would be here, which we'll call lowercase d. Okay, so then the area of a rhombus is capital D times lowercase d. So the long diagonal times the shorter diagonal, but this is divided by 2. Now, why is it divided by 2, you might ask? Well, think of it. If you were doing just capital D times lowercase d, what you'd actually be doing is the larger rectangle around the rhombus, but it would include all of this space that you don't actually want. If you're looking at this version, it would be the same. You'd actually be doing a rectangle that has double the area. So we divide by 2 to get rid of that extra space. So let's do an example. If we had, this can also be called a kite shape. If we had a kite shape that had the capital D as 6, I don't know, let's say hectometers, and this as 2 hectometers, then you'd say the area of the rhombus is equal to capital D times small d divided by 2. So I would have 6 times 2 divided by 2, 12 divided by 2, and that would be 6. And remember, your units are squared. So the area of a rhombus is the harder one. The area of a parallelogram goes back to the language that we were using for other area. And it's very much like a rectangle. So the area of a parallelogram is base times height. Now the only thing that you have to consider in this is what the base and the height are. When we have our parallelogram, the base is, like in a rectangle, what it's sitting on. But the height has to be the perpendicular distance from the highest point. So it's not these edges, it's where it's perpendicular. So you can find it inside the parallelogram, or you can have an imaginary line connecting outside the parallelogram. That would be the height. But it's very important, this is not the height. So for example, if you knew that the dimensions of a parallelogram were 7 meters, 5 meters here, and then inside it was 3 meters, you'd know that the area of a parallelogram is base times height. So 7 is our base, that's pretty easy, but the height is where it is perpendicular, and therefore it's times 3 meters. Both of these are meters, not 5 meters. So you'd have 21 meters squared. Just a short note that a rhombus could also be thought about as a special kind of parallelogram. And so if you were given the height and the base, then you could also figure out the parallelogram area, the rhombus area, using the parallelogram formula. The last one for today is area of a trapezoid. So, a trapezoid can have a regular or irregular shape, but it doesn't matter because the formula is always the same. The area of a trapezoid is, we're going to call this the base, but it's capital B because it's the big base, and then this is going to be small b because it's the smaller base, and these two are going to be added together and then multiplied by h, which is the height, and this is then divided by 2. And what you can think about it as, if it helps, is that basically you're taking the average of the bases. So you're taking this little piece off, you're putting it here, you're taking this piece off and putting it here. So you're averaging out the bases and then making it, if you will, into a rectangle of that size. So when you average these out by adding them and then dividing it by 2, you end up having a formula very similar to that of a rectangle. So if I had an example then to show this, the area of a trapezoid, when I've been given that this is 3 decameters and this is as the height, this is 9 decameters and this is 7 decameters, I would have the big base, the larger of the two, so 9, plus the smaller of the two, 7, times the height, which is 3, but this is divided by 2. And remember, it doesn't matter whether you divide these by 2 and then multiply, or you divide the whole thing by 2, it's going to end up being the same. Therefore, I have 16 over 2 times 3, and that's 8 times 3, and all of these were in decameters. So my answer then is 24 decameters squared. And word problems for this will look very much like the word problems that we did for rectangle and triangle.